Alright, Sasrika students, let us discuss what is the concept of resistors in series. Well, we know a resistor is something where the current flows with some resistance. In the conductor, the current flows comparatively much easier. And in the insulator, we can say that the current doesn't flow at all. Let's say we are talking about this system where we have n number of resistance connected end to end. This is the meaning of a resistance R1 connected end to end. This could be the starting and end of resistance R1. Now this could be the starting of resistance R2 and end are connected in series in the same line. Well guys, it could be like this also. One resistance, second resistance, you know, instead of just drawing it straight away, I could also draw like this. Well, these four resistances are also connected end to end and hence in series. Now guys, number one, we want to discuss what is the equivalent resistance. What is the concept of equivalent resistance? The concept of equivalent resistance is if I want to go away with all these three resistance, I want to know the resistance of this whole system. Obviously, then I will have to replace these three resistance with one resistance. How much would be the value of that resistance? In this case, in series, R equivalent would be equal to R1 plus R2 plus R3. Very simple. Now, if you want to find out the current flowing and if you want to find out the voltage across every resistance, let's see how do we do that. Now, let's say the voltage of the battery connected is V. Now, if you want to find out the current at this point or at this point, let's say if you want to find out the current here, obviously you will have to attach a ammeter here, which not only detects but also tells the measurement of current in milliampere or in ampere. Now guys, very simple. If V is the voltage, the current here, would be simply I is equal to V by equivalent resistance. We know what is equivalent resistance. Equivalent resistance is R1 plus R2 plus R3. Now guys, we want to know what is the voltage across first resistance. The voltage across all the three resistances V. Now what is the voltage across first resistance? In order to find out, we can connect a voltmeter across the first resistance. Interestingly student, this voltage is V1, not same as V. Now the voltage across second resistance would be V2 and the voltage across third resistance would be V3. From the Ohm's law, you know very well that V is equal to IR. So how can you find out the voltage V1 across the first resistance? Now guys, interestingly, it would be the current flowing through this multiplied by resistance of this, and that is IR1. What would be V2? V2 would be current flowing through this that is I into R2. And what is the voltage across the third resistance? V3 would be I into R3. Now guys, you have seen I've not taken I1, I2, I3, right? This simply because the current flowing through each point in this circuit is same. I is same. Interesting. Now, what is the total voltage of uh, the system? The total voltage is V. Now V is equal to V1 plus V2 plus V3. And V1 plus V2 plus V3 we already know. I is common, that is equal to R1 plus R2 plus R3. And just now students we have derived that R1 plus R2 plus R3 is equal to equivalent resistance of the system. You cannot say equivalent resistance of first, second or third resistance. It is equivalent resistance of a system. So that is equal to I into R equivalent. So from this we can derive that current flowing at any point in the system is equal to complete voltage, total voltage divided by R equivalent what we judged in the static. So guys, to sum up, what we have seen, when the resistance are connected in series, what is same? Students, what is same? Flowing through
Current.
the current flowing at every point of the system is same. Whether you connect ammeter here, whether you connect ammeter here, 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 anywhere, the current would be same. It would be better if you do this experiment in your lab also. You'll really be excited. Now, the voltage across every resistance is different. That is V1, V2, V3. Now guys, we quickly go to the second case when the resistors are connected in parallel. Students, this is the diagram of resistances, three resistances which are connected in parallel. Now again, the question is, what is the equivalent resistance of the system or the resistance of the whole system? Guys, this is the shape of resistances connected in parallel. You could remember by remembering two parallel lines. They're like this. So one resistor and second resistor, third resistor. Now guys, in this case, the voltage across every resistor is same. You could intuitively understand if you put a voltmeter here, it's just like this voltmeter, right? These readings of voltmeter across every resistor would be same. Here, voltage is same across every resistor. All right. So what is equivalent resistance? I would tell you guys. How do you find equivalent resistor? 1 by equivalent resistance of the system is equal to 1 by R1 plus 1 by R2 plus 1 by R3. From this, you could find out the equivalent resistance of the system. All right. How can you do that? You just see R equivalent, 1 by R equivalent is equal to, take LCM, R1, R2, R3, and here you get R2, R3 plus R1, R3 plus R1, R2. All right, guys. So you could say that equivalent resistance is equal to reciprocal of this R1, R2, R3 divided by R2, R3 plus R1, R3 plus R1, R2. A similar equation can be done for n number of resistance. Am I right? For example, The equivalent resistance for two resistors would be R1 R2 divided by R1 plus R2. Alright guys, this is one thing. Now, the second thing, as we have seen, that the voltage across every resistor is same, and that is V. If you put voltmeter here and here. Now V is equal to always product of current and resistance. Now resistance of this is R1, and this V, the second one, is equal to what? I into R2. The third voltage is I into R3. Now guys, from this, whatever I have stated is not complete. We know voltage across every resistor is same. Am I right? That's why I have not named V1, V2, V3. Rather, I have named only V. In case the current flowing through every resistor would have been same, then V wouldn't have been same, because same thing into R1, same thing into R2, same thing into R3 would yield different results. So from this judgment of mathematics and actual judgments by doing this experiment, we come to know that the current flowing through each resistance when the resistance are connected in parallel are, tell me students, current flowing through each resistance, students please speak, when the resistance are connected in parallel, the current would be, students please speak, the current would be, different. I1, I2, I3 value would be different, and sum of I1 R1 is V1, sum of I2 R2 is again V, I'm sorry, not V1, V, and the product of I1 I3 R3 is again V. So this is the case here, right? Here we have explained the complete things about how the resistances are connected in parallel and series. Students, it is interesting to find out when the resistances are connected in parallel, the total current I would be equal to I1 plus I2 plus I3. That means current flowing in the first, second and third resistance. Now, let's derive this from this. Since I is what? I is the current flowing in the whole system. And how can we find or visualize the current flowing in the whole system? By reducing the whole system of three resistances to one resistance, and that resistance would be equivalent resistance, and that we have already stated is equal to 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now, according to Ohm's law again, I is equal to V by R. Am I right? So let's find out. Now this current is the equivalent current. I1 is not equivalent. I1 is the current flowing in first resistance. I2 is the current flowing in second resistance. And similarly with I3. So I would be equal to what? V by R. Now what V would be total voltage. V. And V everywhere is same, so fine. And V by R. So what R it would be, students, now? Whether it would be R1, R2, R3 or R equivalent. This is a current flowing in the whole system. When you talk about whole system, then it will be equivalent. So this is equal to IA1 is equal to V by, can anyone tell? I1 would be V by
R1.
R1. Yes, we don't write V1 here. Why? Because we know voltage everywhere is same. So what it would be, students? Please complete. I2 would be
V by R2.
correct. And next V by
R3.
Now you see, students, again you apply mathematics. Take V common from here. It cancels with V. What remaining is again the same formula which we stated in the starting. What 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. All the best. Enjoy this, share with your friends, and wait for more videos on electricity. Thank you.